Welcome. Today we are discussing Module 7.1, Synthesizing the Final Answer and Hallucinations, Theory. Here is a quick look at where we are in our curriculum. Welcome back. Today we are tackling the silent killer of production RAG systems, the synthesis bottleneck. Many engineers think that if their vector search retrieves the correct documents, the system is bulletproof. But in reality, feeding raw search results into an LLM often leads to incomplete answers, context omission, or outright hallucinations. In this module, I will explain exactly how LLMs process this context and where things break down. If you want to follow along with the visual assets, please check the link in the description to download the architecture diagrams and script templates for this module. Let us break down the anatomy of a hallucination. It is not just the LLM making up random stories, it is a systematic failure of two core metrics. First, faithfulness, meaning, is the generated response strictly derived from our retrieved source documents? Second, answer relevance, meaning, does the response actually address the user's question, or did it get distracted by noisy, irrelevant chunks that were accidentally retrieved? Understanding this distinction is key to designing robust evaluation pipelines. Take a look at this system design. Instead of directly dumping retrieved documents into the LLM, we pass them through a context compressor and ranker. The LLM then receives a prioritized list. After generation, we don't just send the response to the user. We route it through an automated evaluation loop that checks if the answer aligns with the context. If it fails, the system self-corrects or falls back to a safe default. I highly encourage you to check the link in the description to download this architecture diagram and script so you can map out your own workflows. This sequence diagram illustrates the complete workflow. Notice how the evaluator plays a critical gatekeeper role between the LLM and the client, ensuring no unverified answers are leaked. Now let us translate this theory into structural logic. We can build a programmatic checker using Python. In the code shown on the screen, we define an evaluator class that scores the generated answer against our source document facts using semantic similarity and containment checks. If you want to run this code on your machine, remember to check the link in the description to download the architecture diagram and script. Here is the production-grade code. We define a standard function to check if the generated answer relies purely on retrieved contexts. We analyze overlap and compute a strict faithfulness index. If you need to debug or test this script, make sure to check the description link to download it directly. Now, let us examine how this runs in production. When we run our script, notice the console logs flagging the hallucination about Martian rocks, because that fact was never in our retrieved Apollo 11 text. This terminal log is exactly what you want to see inside your CI/CD pipelines to ensure absolute safety. To summarize, never trust an LLM to blindly synthesize facts without a programmatic safety net. We have covered the theory of synthesis, categorized hallucinations, and built a code-based gatekeeper. In our very next lecture, Module 7.2, Building a Full End-to-End RAG Script, Practical, I will guide you step by step as we construct a complete, production-grade script integrating vector DBs, generators, and evaluators from scratch. I will see you there.